Breast cancer is a type of cancer that starts in the breast, forming a detectable tumor that will grow out of control. About 12% of women in the general population will develop breast cancer sometime during their lives. Approximately 5 to 10% of all breast cancer is associated with a hereditary predisposition. A recent large study estimated that 72% of women who inherit a harmful BRCA1 mutation and about 69% of women who inherit a harmful BRCA2 mutation will develop breast cancer by the age of 80. Well, what exactly are the BRCA1 and BRCA2 alleles? They are both tumor suppressor genes that help prevent cells from growing and dividing too rapidly or in an uncontrolled way and also function to repair damaged DNA. The BRCA1 gene is located on chromosome 17 and BRCA2 is located on chromosome 13 and are both expressed in breast cells. When these alleles have consequential mutations, toxic cells grow out of control and take over tissues, leading to breast cancer. If women were able to genetically test their DNA to see if they had these mutations, it could change their lives. Besides BRCA1 and BRCA2, some of the other genes that are considered to have risky alleles that could possibly develop breast cancer are ATM, CHEK2, and TP53. Although harmful mutations in BRCA1 and BRCA2 are responsible for the disease in nearly half of families with multiple cases of breast cancer and up to 90% of families with both breast and ovarian cancer, mutations in a number of other genes previously stated have been associated with increased risk of breast cancer and/or ovarian cancer. Now let's talk about variations in specific genes. Oh wait, not that type of genes. Haha, laugh my genes off. For example, BRCA1 RS1692 and CHEK2 RS17879961, however, there are many different variations in specific genes. The BRCA1 and CHEK2 genes are only two of the numerous genes. Many of the gene variations, when found alone, pose no significant risk. This is described as a casual mutation. However, when in conjunction with other mutated genes, such as BRCA1 RS179950, BRCA1 RS4986850, or ATM RS3218695, the chances of genetic breast cancer increase. We have created a genetic test that can identify both casual and harmful mutations in these 5 alleles, but primarily focuses on BRCA1 and BRCA2. Now, who is at risk and should consider getting this genetic test? A harmful BRCA1 or BRCA2 mutation can be inherited from their father. Each child of a parent who carries a mutation in one of these genes has a 50% chance of inheriting the mutation. People who have inherited mutations in BRCA1 and BRCA2 tend to develop breast and ovarian cancers at younger ages than people who do not have these mutations. The United States Preventive Services Task Force recommends that women who have family members with breast, ovarian, fallopian tube, or peritoneal cancer be evaluated to see if they have a family history that is associated with an increased risk of a harmful mutation in one of these genes. When an individual has a family history that is suggestive of the presence of a BRCA1 or BRCA2 mutation, it may be most informative to first test a family member who has cancer if that person is still alive and willing to be tested. If that person has a harmful BRCA1 or BRCA2 mutation, then other family members may want to consider genetic counseling to learn more about their potential risks and whether genetic testing for mutations in BRCA1 and BRCA2 might be appropriate for them. Because harmful BRCA1 and BRCA2 gene mutations are relatively rare in the general population, most experts agree that mutation testing of individuals who do not have cancer should be performed only when the person's individual or family history suggests the possible presence of a harmful mutation in BRCA1 or BRCA2. People will benefit from our test if they are tested positive and are aware of their chances of getting breast cancer. Because they know this information, they can address the risk they are at. One option is a double mastectomy. Double mastectomy is done as a risk-reducing surgery for women at very high risk for getting breast cancer, such as those with BRCA gene mutation. Professional societies do not recommend that children under the age of 18, even those with a family history suggestive of a harmful BRCA1 or BRCA2 mutation, undergo genetic testing for either of the alleles. This is because there are no risk reduction strategies that are specifically meant for children, and children's risk of developing a cancer type associated with a BRCA1 or BRCA2 mutation are extremely low. For our test, DNA, usually from a blood or saliva sample, is needed for all of these tests. The sample is sent to a laboratory for analysis. It usually takes about a month to get the results. People who are concerned should proceed with our test at their own risk. The direct medical harms of genetic testing are minimal, but knowledge of the test results may have harmful effects on a person's emotions, social relationships, finances, and medical choices. People who receive a positive test result may feel anxious, depressed, or angry, or particularly immediately after they learn the result. People who learn they carry a BRCA mutation may have difficulty making choices about whether to have preventive surgery or about which surgery to have. People who have a negative test result may experience survivor guilt, caused by the knowledge that they do not have an increased risk of developing a disease that affects one or more loved ones. Because genetic testing can reveal information about more than one family member, the emotions caused by test results can create tensions within families. Test results can also affect personal life choices such as decisions about career, marriage, and childbearing. We hope you consider our SNP test if you think you are at risk to developing breast cancer. Thank you.